What is an acid? What is a base? What happens when they occur in the environment? And what happens when they mix together? Acids and bases are measured on the pH scale. We can determine pH using different methods. In this video, we'll use chemical indicators and a digital pH meter. On the pH scale, acids have a pH below 7, and bases, also called alkali, have a pH above 7. pH of 7 is considered neutral. The pH scale is a logarithmic scale. This means that one pH point really represents a 10-fold change in acidity. This means that pH of 5 is 100 times more acidic than the pH of 7. This is important to remember later on. When we add universal indicator to hydrochloric acid, or HCl, we can see that it turns red. This is because this chemical indicator changes with pH. Below pH 3, the indicator turns red, so we can infer that this acid has a pH lower than 3. When we add the same indicator to a known base, sodium hydroxide, it turns dark purple. Based on this indicator's properties, it tells us that the pH is greater than 10. Often people think that acids are worse than bases, but if we stray too far from neutral in either direction, living things tend not to be too happy. However, acids do tend to occur more because of the carbon, sulfur, and nitrogen containing compounds found in a lot of emissions that will result in acid precipitation. Acid precipitation is particularly concerning for aquatic ecosystems. Most aquatic species prefer a neutral pH, or near neutral. If the pH drops to 5, fish eggs won't hatch. Remember, this is 100 times more acidic than pH 7. Below pH 5, adult fish start to die as well. So, how can this problem be resolved? Well, initially people thought the best solution would be to simply add a base to an acidified lake. When we add a base to an acid, we should get a neutral compound. But let's look at this a little bit closer. Here, we have a beaker with a digital pH meter to show us the measured pH throughout the experiment. Our water is starting off near neutral, which is what fish and other aquatic species like. But what happens when just a little bit of acid is added to this water? So to combat this decrease in pH, we can add some base, but sometimes we overshoot it and then we drive the water into alkaline conditions, which is also not ideal. We can eventually get back to neutral, but this will take time. And there's another problem we have not considered. Neutralization reactions are exothermic, meaning they give off heat. Check out what happens in this infrared video when we add base to an acid. Temperature is very important for aquatic systems as well, because as temperatures rise in the water, oxygen levels go down. That's not good. Plus, as soon as it rains again, the water will start to acidify. These large swings in pH are not good for aquatic creatures. Using a buffer, something similar to this over-the-counter antacid, can regulate pH, even after more rain, as you can see in this demonstration here. Even though it helps, there are still large swings in pH levels and potentially temperature. This is why neutralizing aquatic systems after the fact is not ideal.